Good morning, I'm Cody Henriksen, and we're going to talk about how we can create JUnit tests for student projects so we can do some cool things with them and learn some stuff too. Now, when we're talking about JUnit, we want to look over some of the basic stuff for this. So what JUnit is, it's a unit testing tool, so you can test if Java programs are executing in the proper way they should be. We've got two different parts we'll be looking at. We have a test case and a test suite. We're going to be looking at test cases in this assignment because we're just doing the beginning basics for it. But as you work with this and do more, you can always add a test suite so you can test even more. A test case tests one single class, just one, at a time. And so I like to give them a really easy name like class name test.java so you can know exactly what we're doing. Again, trying to use good naming conventions when we're working with students really helps us and them understand what we're doing. The next thing we have is a test suite. The test suite is how I can run all the different test cases that belong to a package, including its sub-packages. So if you're like me and use like multi-package structures across your projects, you just do the root part of the project for the package name and it'll test all the tests that are inside that, or you can do it and run all the tests that go inside and to have it just by subtest group. Lots of cool stuff. And with those, I give it the project name testsplural.java so I can identify that it's a suite itself and it's running a group of tests rather than simply just one set of tests at a time. One of the really amazing features of JUnit is it allows you to, as a teacher, to define the scope of a project. So you can, hey, this is what I have to measure as part of my project. And so when you're writing the tests themselves and putting it together, you as the teacher can identify, here's what we have to do, what we have to measure for this project. It also helps to identify for students what they need to do as well. It's also a great way you can use this to work with rubrics and identify so students can understand what they're doing and what they're working on as they go through the project. And if you release this early on, students can work on it throughout the entire course of the project and they can check their status as they go along. Annotations. Now this is one of the things that specifically we have to use when we're working with JUnit because JUnit, especially the newest version, JUnit 5 and 4, those require the use of annotations as part of the actual structure so you can write the test properly. These are pre-compiler notes, as all annotations are, like the override you'd see on a lot of the code you'll see in my videos. They all start with the @ sign, which is just a little notification saying, hey, this is not for the compiler read, but for happened before so. Case, of course, matters because, again, we're talking programming land, and so case is a big deal. There are a bunch that JUnit requires, but the basic ones that we have to have are the @ before each, @ after each, and @ test. And like they say, the words themselves tell you exactly what's going to happen before every test, after every test, and the test itself. Easy way to identify what you're working with and which ones we're talking about. We also need to identify what we need to test. Now, especially we're starting with this beginning of this, we want to make sure we test that data members are properly initialized. If we're testing a void method, we want to make sure that they change internal state as necessary. And if it's working with a method that has a return type, we want to make sure they return both appropriate and correct values. Now, if they give, for example, a wrong answer, but it's the right kind of wrong answer, we can pass part of the test or some of the tests, and then we can have the correct answer be an even more correct version. So it's a great way you can test lots of different things using the basic structure of the JUnit test. There are some things, however, we don't want to test. Now, this is, of course, personal opinion. This is Cody Henriksen talking. This is not some guru of testing, but I don't recommend testing getters or setters as an actual test structure. The reason for that, with getters and setters, they're one-liners in Java. They really should be simple things that automatically execute properly. There's no calculation, there's no computation. It's just code, and it's just a single line, just blurb, return or set. That's all it does. And so, as such, we don't want to take the time to actually write out all the tests for that. But rather, instead of actually testing the getters and setters, we can handle them with logical tests inside the constructor or inside other parts of the code to make sure we have the correct values on that. Now, if you're doing full test-driven development, or TDD, as I have mentioned right here, then of course, yes, you want to have all the tests written in advance and make sure the students correctly pass and initialize all the values as they go along and correctly initialize every single thing and test everything as they develop the actual code. But again, we're talking about the beginnings of JUnit and beginnings of unit testing, and so we don't have to do everything. We just have to do what is functional and move on. And especially right now when we're talking in this COVID exercise type world, we want to make sure we have something we can provide for students and give them tools, but don't overwhelm them all at once. Another thing you don't want to test are methods that only display information, whether it be pop-ups or a stack of print or println statements. There are actually ways to test those, but printing out console output or printing out pop-up windows and actually checking to make sure the pop-up exists, that's not really what the functionality, that's making sure that's something that will be handled beforehand, pre-testing phase, because you want to make sure they can do system.println properly and making sure they're properly outputting that. And that's, again, this is where we'll have the idea of using the generated value, make sure the value itself is correct versus how it actually shows up on screen. And so that's where we want to test those as well. On test types, we've got a couple different test types we can do. We can check on booleans, on integers, floating points, both with and without a delta, because with a floating point and a double, we don't have an actual equal value, but we can give a delta value, so it's like, oh, is it squishy enough? And yes, and you can make it do some really cool stuff. You can also check either for or against null, whether or not objects are equal or not equal, of course. And then you can also look inside arrays. And so you can do all the basic functionality you need to do to make sure your actual project code works properly. And you can do all of that by using just some really basic, simple statements that all start with assert and whether it's true, false, or whatever. You also want to make sure when you're doing your test types, you provide students a message. You don't want to leave the resulting execution of that blank because you want to actually help the students solve the problem. And so when you're writing the unit test, you want to make sure that the message that goes after the test itself properly describes what's going to happen. And so that's where you can have that fixed appropriately. When we're talking about how to test, we want to make sure we can do some really basic stuff. So we have an example over here on the right. The first thing you want to do is you want to start small. You just want to do one class for your project for your first one. So just pick one, pick an easy one, pick something basic. I'm using right now the Celebrity Lab to do the examples I'm working with for this. You create the file that's called class_test.java file, so in this case it's celebrity test. You want to make sure you make an instance of the class you're testing as a data member, of course private because we're calling good information hiding practices, and you make sure inside there is a data member for that. You also want to create your setup and teardown methods. Now as you can see right here in the setup and teardown methods, they're both void type methods, and they throw exceptions that could happen if there's something to be going on with it. And these initialize both before and after every single thing. In this setup, you want to initialize your variable you've declared with a value that makes sense, something that's easy to test. In this case, we have a test lab as a new celebrity with celeb name and why am I famous. And in the teardown, just initialize it to null, because that way it automatically recreates it as needed, and you can test all the appropriate values every time you single run the tests. And so that's just the very, very basic. It doesn't actually do anything, but it gets it ready to go on. The first thing we're talking about is we want to make sure we can write a constructor test. When you write a constructor test, you want to name it test and then class name because you're testing the constructor. Now, if you're having a multiple parameter constructor, you want to test specifically the multi-parameter instructor versus a single parameter instructor or a no parameter instructor, then you want to give the appropriate information as part of the method name itself, so test class name string parameter, or test class name string string, or something like that so you can identify which constructor you're testing easily when you're looking at the actual thing. But in this case right here, since there's only one real constructor we have to worry about when we're talking about the celebrity example, I simply have test celebrity that we're working with. We also want to make sure we check the minimum internal state. Again, when we're doing our first set of tests, we don't have to test everything. We want to test for the very minimal states. This is where we want to check that our getters function properly because we've initialized our data members and we use the getters to retrieve that value and appropriately use it. We want to make sure you assert not null for all object-based data members because if you have an object data member, they should never be null after the constructor itself is finished. So that's a great way to verify they've correctly initialized every data member properly. And then you want to check values for correctness after the actual initialization phase and after the not null step, because at first you want to make sure it's there, then you want to make sure it's correct. So you have the correct type of value and you have the correct actual value itself. With that test celebrity projects, we have our test celebrity method right here. Again, it says the @test annotation right in front. Assert not null test celeb.getAnswer, even celebrities need names. So it should have an actual value in there. Assert not null get clue. You can't play a game if the clue is null. Wouldn't work. And then after we've tested the null status, we then check to make sure the content is actually there. And then we use the assert equals method. We pass it the test celeb.getClue again. Why am I famous? Question mark. They should match exactly as what we saw as the parameter passed up there. And these really ought to match. So we can see exactly what should be going on when we're running that correct test. And we can see how it works. When we're writing method tests, we want to make sure on a return type method, we want to make sure all computation or calculation is done appropriately. We define a variable with the value we expect to be receiving from that method call. We write an assert equals or assert true or assert not null, whatever assert type we're checking. We pass it the method call, the variable we're working with, and a message to display after it fails the test. If we're checking a void method, we want to make sure the internal state is properly modified. One of the biggest things you're doing when you're talking about writing a good void method test is making sure that the parameters have been assigned to data structures and that the order of those structures is either correct or the size is correct, because that's where we're looking through that. And so we're using a void method, we want to check for that internal state and look inside that. We have an example of a toString method right here, so we can see that inside our string celeb contents equals name. So we should have name mentioned somewhere inside our celebrity when we talk about toString, because this is a celebrity, its name is blah, 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 and they're famous for blah, blah, blah. And so assert not null, test celeb.toString, there's never a good reason for the toString value to return null, so that should be a great way to verify that. And then assert true, test celeb.toString.contains, or .index of, or any other way we're going to verify that's true, and then passing that celeb contents, that string we just defined right there with null. And a celebrity should have details. Again, explaining what we should be seeing inside that, and you should make that be as explicit or as implicit as possible so you can make sure that students can actually solve the problems you're looking for when they're doing this. When you're running tests, all you have to do is after you've written the test files, the Java themselves, you can just add them to the project by either dragging and dropping them into the actual folder of your Eclipse project or using the right-click and choose import and go from there. To run the tests, all you have to do is click the JUnit coverage run icon. It's up in the top left and hope for green. We can identify our failure points. The first thing we'll see is the red bar of sadness. I know, tears. We want to look at the test list on the top, and so we can identify what kind of problems we're having. A black X in the bottom left corner says it's a failed test. Our red X in the bottom left corner is a runtime error, but if we get a green check marks, yes, I know it's great. We find the details of each failed test, whether it be a runtime error or a failed test error, in the failure trace, and so you can see what the actual information problems are. However, the first thing we want to note is that we only get the information for the first failed assertion. So we have to fix each thing as we go through, and that's one of the great things about doing this, is it really encourages iterative development and iterative solutions rather than just the piecemeal approach. And so we can see right here a couple of failure examples. We have the test celebrity get answer has a failure right there with that black X in the corner. When we look at that, it says that we have a getter method to return values, expected something not null. Because in my example I have for the code right there, I have a null return because I did not assign values. We have a runtime error right there with the test celebrity. We have an X right there in the corner, and you can see right there it has a null pointer exception because there's a null value, and it gives a failure error on that because it was not testing for null. And so when it hits that null pointer exception, it tries to run something on that. A null dot whatever causes null pointer exception, and it won't work. And so you want to make sure you have students look for the different things between an error versus a failure. And you can also see that up there, as you can see in the top row, where we have the runs, errors, and failures. Errors are problems in the code the students must fix first, and then failures are how they can actually identify the code and make it to execute properly. We have our green bar of joy right here. As you can see right here, when all the tests execute properly, you get this really great green bar of happiness. And this is something you can really use as a way to check off things. Even if students are having problems with something, they don't get something totally complete, if they turn in a screenshot of this and provide some annotation, they can do some great information to explain what they did wrong and how they can do a better job next time. How you can turn off coverage highlighting. And one of the things you can see sometimes when we're working with JUnit is get those really weird highlighting of the green and red of the code itself. And if you don't find that very useful, go to the window menu, click on Show View, choose Other, then Java, then go to Coverage. It'll bring up this pop-up window right here you can see right there, and find the double X's in the corner, and click that, and it'll take out all the highlighting. I myself don't find the highlighting very helpful, so I like to turn it off often, but that's a great way you can turn it off if it becomes distracting for you. How this can be worked with students. So one of the reasons I really like this is a great way to work with students and working especially on bigger projects so they can solve things appropriately. This encourages iterative development because they can have to solve each piece, and it doesn't tell them all the errors at once. It tells them here's the first error you hit, boom, and then how to fix it. You're giving them a suggestion on what they need to do to make that code properly execute. The students can use the fact that they can run the test before they even write any code, like, oh, this isn't working, this is what I have to do, and they can identify the points they have to work with to fix and start writing code to actually do things. I recommend that you also demonstrate what a test failure looks like and how to fix it. Students, by seeing how to fix the error and what it looks like when an error is fixed, it's a great way to demonstrate how it goes through and what to do with this. The green bar of joy, stress the happiness. It's a great thing you can do to show them how they're like, hey, I've got this fixed, I'm good to go. I work with this on students by having it be an assignment. This is how they turn in the completion of their work. They can submit their JUnit status, and if it's a green bar of joy, full credit. If it's a mixed selection, they don't get full credit, they get partial, and they can resubmit that as necessary. One of the also tools you can use, like I said earlier, you can have students submit an annotated screenshot. So it's like, hey, I've got a failure right here. I've tried this, 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 and this, and I don't know why it's not failing. The message, I've corrected this, and that's a great way they can come back, and by forcing them to actually reflect on it via screenshot and annotation, it gives them a chance to come back and work on it again later. And also, again, when we're working with students, keep this as stupidly simple as possible. Use that KISS principle and make it so that with students, they don't have to test everything. Test the minimum you have to do. Make sure you can use this so they can identify what they have to do to fix something, and then go from there. We don't want to test everything to overwhelm students. We want to use this as a way we can actually create a tool for students to use to help identify what they're working with and do some cool things later on. That's what we're going for. Thanks again. Have a great day.